tried to go over some slides, and it led to a lot of discussion, and that was very good because I think it was very useful to understand some important aspects. Similarly, when I was looking at the slides today, I felt that some of them are really peripheral, which means that you really, even if we skip it, it won't matter. But the slides that are really have a lot of information which is useful and effective, we will spend some time, and in case we need to have discussion, we'll have more discussion also. All right. So before I start, and pick up a few points where we left off, anybody has any comments or questions on the discussion that we had yesterday? Now, if you look at your notes, we have, this is a 5th lecture, and after that there are 4 more lectures, and we have only 1 day left. So what I will do is that we'll try to finish the discussion, and I think that this is a very important lecture with a lot of information about the computational techniques. So in case we need to have the more discussion, that's fine. And after that, we will go into the applications, and some applications, we may altogether not consider, because I don't think many people in the audience may be interested in that. And then consider some other applications, which may be more of interest. Okay. So where we were yesterday is that, and that is the key aspect of this entire presentation, that how do you incorporate in the Fluent framework using the numerical techniques that are there to include the effect of surface tension forces, because of the presence of its second phase, and there is a interface between the 2 phases, and that interface between the 2 phases includes the surface tension. Okay. So that is the main thing that we were trying to drive yesterday, and that led to a lot of discussion. So if you remember that this is the equation that we are considering, and if you look at in this equation the surface tension forces, that is a novel part of this equation. Otherwise, the standard software does not include it. So standard software includes the pressure, the viscous, and the gravitational forces. So we were discussing that this surface tension force, which only occurs if you have this interface between the 2 fluids. So it could be a bubble which has air bubble and surrounded by a liquid, just for a simple example. The question is, how do you include that particular surface tension force, which requires that you have to model the interface. So that is what we discussed, that how do we model the interface yesterday. And one of the methods that we discussed is the volume of fluid method, which is the most well known and widely used method. We went over the whole history of that method and how do you incorporate it. So that is where we had this VOF equation, which is like a advection convection equation, and then we went into how do you solve that equation on an interface, and then we went into the whole methodology, and we have an enormous amount of discussion that how do you do that to incorporate it. The bottom line was, after we went through all that discussion yesterday, that it is possible to incorporate it and solve this equation, and then eventually what you have is that you can then get from the VOF method the information about the curvature at the interface, that is kappa, and then the surface tension is known, and then this term can be modeled like a pressure term, P dot. We introduced a term P dot, and once you can introduce that pressure term and the pressure equivalence of this particular term, and this was shown that how do we do that. So then this becomes this pressure equivalence of the term, which is just like the pressure term. So this becomes the surface tension term, and then you can combine the two and again apply the simple algorithm that is built into Fluent, and that is how the Fluent solves this particular problem. So we went through this, and then we discussed the continuous surface method and the sharp surface method, and we found that if we have a sharp surface method, then we can calculate the interface very sharply. So we went through all this and went through this method, which basically shows that how do you calculate the interface. But the main thing I wanted to drive home was that within the numerical framework of Fluent, by following this particular procedure and using the volume of fluid method, you can incorporate the interface, which has a surface tension effect, and then you can solve these multi-phase fluid flow problem. And then this slide basically shows that you have two methods. This is the continuous surface method, which is a numerical, of course, solution of the alpha equation, and this is the sharp surface method, and the sharp surface method can capture the interface very sharply through the delta function. So that is where we were, and then we left it off right exactly at this place because of the lack of time. And so I will just now pick up from here and introduce a few more slides, and after that we may have few more minutes of discussion, and that will be closing this chapter. All right. So that is where we were. So if you have a surface tension because of the presence of two phases or the interface of the two phases, and for simplicity let us consider the bubble into a liquid. So you have air bubble and the liquid phase, and so in that case, and I showed you a video also, that the dimensionless numbers that